Hey there, fellow knowledge seeker. Welcome to a deep dive that gets to the core of how AI learns.
Yeah.
We're going to be dissecting this research paper from MIT and Johns Hopkins.
Mm-hmm.
It's making waves in the AI world right now, and trust me,
Yeah.
you are going to want to hear this one.
Absolutely. The paper we're exploring today is called Randomly Sampled Language Reasoning Problems Reveal Limits of LLMs
Okay.
by Kavagupta, Kate Sanders, and Armando Soler-Lizama.
Okay, so we don't know LLMs are having a moment, right? I mean,
Yeah.
they can write poems, they can code, they can translate languages. Like,
It's impressive.
it's mind-blowing.
Yeah.
But this research asks a really important question.
Mm-hmm.
Are LLMs truly learning and understanding language,
Right.
or are they just masters of mimicry?
That's the core question
Yeah.
that this paper is trying to investigate.
And get this, they didn't use like some obscure human language for this test. They created entirely new languages using something called deterministic finite automata, or DFAs.
Yes.
DFAs.
Think of a DFA as like a set of rules that defines a language.
Okay.
A little bit like a simplified grammar that governs how symbols can be combined
Right.
to form valid sentences.
So it's like creating a whole new system of communication from the ground up.
Exactly.
That's brilliant. I mean, that means that the LLMs can't just rely on
Right.
their vast training data. They have to actually figure out the logic
Yes.
of this new language
Right.
to test this. The researchers gave the LLMs two specific tasks. Using these DFA-generated languages, first they asked them to complete sequences in the new language, kind of like predicting the next word in a sentence.
Mm-hmm.
And second, they challenged the LLMs to act as what are called transducers,
Yeah.
which means converting sciences in the new language into specific outputs.
Exactly.
So it's about seeing if LLMs can not only understand the structure of this new language, but also gives it to perform specific actions.
Yes.
That's a pretty high bar.
It is a high bar. And the reason why they chose those specific tasks is because a lot of the applications we imagine for AI in the future will involve interacting with systems that use unfamiliar, non-human languages.
Oh, I see. So like robots communicating with each other.
Exactly.
Or AI analyzing complex biological data.
Yeah.
If LLMs struggle with these DFA languages, then that could have implications for a whole range of
Fields, exactly.
And now for the moment of truth, the results of the experiment
Yes.
were quite unexpected.
We're a little bit surprising.
Even when tested on relatively simple DFAs, the LLMs consistently struggled.
Yeah.
Wait, really? So these powerful AI models trained on mountains of data couldn't crack the code
Yeah.
of these relatively simple languages.
That's right. And what's even more surprising, that they were outperformed by a much simpler model.
Oh,
A basic ngram model.
ngram models, aren't those like
Yeah.
bare bones of language modeling? They just look at the frequency of word sequences?
Yes.
They don't really understand the deeper meaning, right?
You're exactly right. And that's what makes these findings so interesting. It suggests that LLMs, despite their apparent sophistication, might be relying heavily on pattern recognition and memorization rather than
Interesting.
truly grasping the logic of language.
So it's like they're acing the test without really understanding the material.
Yeah.
That's fascinating and a little bit unsettling.
Yeah.
There's a specific example in the paper,
Yes.
the sum modulo 3 DFA, that really highlights this, right?
Yeah. The sum modulo 3 DFA is a great illustration of this point.
Okay.
It's a simple DFA where the rule is that the sum of the symbols in a sequence must be divisible by 3 for it to be accepted.
Okay.
So it's essentially a basic mathematical check embedded within a language.
Okay, I'm following. So it's like a little puzzle.
Yeah.
It requires understanding a simple arithmetic rule.
Exactly.
How did the LLMs do on this one?
Well, even on this relatively familiar point forward DFA, the LLMs still seem to rely on surface level pattern matching rather than actually grasping the mathematical concept.
So they're not really understanding the math, they're just mimicking patterns they've seen before.
Right.
Like they're solving the problem by brute force instead of
Yeah.
using actual reasoning. That's kind of a big deal, isn't it?
It is a big deal.
Yeah.
And what's even more intriguing is that the researchers tried various prompting strategies, including sophisticated chain of thought prompts, where you essentially guide the LLM to think step by step.
And did that help? Did leading them through the logic improve their performance?
Unfortunately, not reliably, even with those advanced prompting techniques.
Yeah.
The LLMs still couldn't consistently grasp the underlying logic.
Wow. Okay, so we've established that LLMs have some pretty significant limitations when it comes to truly generalizing to new languages, even relatively simple ones.
Exactly. And that raises a whole bunch of questions about
how we develop and use these systems in the future. Right. If they're struggling with the basics of understanding a new language, what does that mean for
Right.
more complex tasks? And what does this tell us about
Exactly.
how LLMs learn compared to humans? We'll explore those questions in part 2 of this deep
For
dive.
sure.
Don't go anywhere. Welcome back. I don't know about you, but my mind is still buzzing from that first part.
Yeah.
It's pretty wild to think that these superpowered AIs might not be learning language
Right.
in the way we assumed they were.
Yeah, it's definitely a thought-provoking finding.
Yeah.
And it has some pretty significant implications for how we think about
Right.
the future of AI development.
Right. I mean, we're seeing LLMs being integrated into so many different areas.
Yeah.
Everything from chat box to medical diagnosis.
Mm-hmm.
But if they're hitting these fundamental roadblocks,
Right.
when it comes to generalizing to new languages, does that mean we're putting too much faith?
It's a valid concern.
Yeah.
This research really underscores the importance of understanding not just what these systems can do, but how they're doing it.
Right.
Just because an LLM can produce human quality text or solve a specific task
Right.
doesn't mean it possesses a deep conceptual understanding of the underlying principles.
It's like that saying, give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime.
Yeah.
We've given LLMs a vast ocean of data,
Right.
but maybe we haven't quite figured out how to teach them to fish.
That's a great analogy.
Yeah.
And this paper really sheds light on that distinction.
Right.
If LLMs are primarily relying on pattern recognition and memorization,
Yeah.
as the findings suggest, then they're likely to hit a wall. When faced with scenarios that require genuine generalization and understanding of
Yeah.
new concepts.
So what's the solution? Do we just give up on LLMs? Surely there must be ways
Yeah.
to address these limitations and move forward.
Absolutely. This research isn't a dead end.
Yeah.
It's more like a signpost pointing us in a new direction.
Yeah.
It's a call to explore new approaches to AI development
Mhm.
that go beyond simply feeding these systems more data.
Okay.
We need to think about how to cultivate true understanding,
Yeah.
not just superficial mimicry.
So it's about moving from quantity to quality.
Exactly.
It's not just about the size of the data set,
Yeah.
but how we can help LLMs learn from that data in a more meaningful way.
Exactly. And there are some promising avenues being explored.
Okay.
One exciting area is neurosymbolic AI,
Okay.
which combines the statistical power of neural networks
Uh-huh.
with the logical reasoning capabilities of symbolic systems.
So it's like trying to merge the best of both worlds.
Exactly.
The pattern recognition prowess of LLMs
Yeah.
with the rule-based logic that we humans use to understand the world.
Exactly.
Could that be the key to unlocking true language understanding?
It's definitely a promising direction.
Yeah.
Another approach that's gaining traction is few-shot learning,
Okay.
which focuses on developing models that can learn new concepts
Yeah.
from just a handful of examples.
That makes sense.
Much like humans do.
We don't need to read a million sentences to understand a new grammar rule.
Exactly.
We can often grasp new concepts quite quickly
Yeah.
with just a few well-chosen examples.
Exactly.
If we can replicate that ability in LLMs,
Right.
it could lead to systems that are far more adaptable
Yeah.
and efficient learners.
Precisely. And ultimately more intelligent in a way that reflects
Yeah.
the flexibility and nuance of human intelligence.
This is giving me some hope. It sounds like we're starting to move beyond simply
Yeah.
scaling up existing models
Right.
and really grappling with the fundamental challenges of building AI systems
Yeah.
that can genuinely understand and reason about the world.
I agree. And as researchers continue to push the boundaries in these areas,
Yeah.
we might see LLMs evolve from powerful tools
Mhm.
into true partners in knowledge discovery and problem solving.
That's an exciting thought. But even as we explore these new avenues,
Yeah.
there's still that lingering question about what this all means for our understanding of
Right.
human intelligence.
Right. If these sophisticated AI systems are struggling with something, that comes so naturally to us.
Yeah.
It raises some pretty profound questions
Yeah.
about the nature of our own cognitive abilities.
Exactly. If LLMs are so good at specific tasks, but stumble when it comes to generalizing,
Right.
what is it about the way we learn that allows us to so effortlessly navigate
Yeah.
new linguistic landscapes?
That's a question that takes us into the realm of philosophy and cognitive science.
Right.
And it's one we'll delve into in the final part of our deep dive.
Okay.
Stay with us.
Welcome back to the final part of our deep dive.
Yeah.
We've been unpacking this fascinating research
Right.
that's revealed some unexpected limitations in LLMs.
Uh-huh.
They might be able to write a sonnet in the style of Shakespeare.
Yeah.
But when it comes to truly understanding and generalizing to new languages,
Right.
they're still hitting some serious roadblocks.
They are.
And that leads us to a really intriguing question. What does this all tell us about human intelligence?
Yeah.
If these AI systems, with all their processing power and access to data, are struggling with something that comes so naturally to us, is there something special about the way we learn language?
It really makes you wonder if there's a secret ingredient missing in these AI systems.
Yeah.
Something that allows us humans to effortlessly adapt to new linguistic environments, to pick up nuances and infer meaning in ways that LLMs still struggle with.
It makes you wonder if there's like a secret sauce missing in these AI systems.
One prominent theory is that human language learning is deeply intertwined with our understanding of the world.
Okay.
We don't just learn words and grammar in a vacuum.
Right.
We learn them in the context of our experiences.
Yeah.
Our interactions with the physical and social environment. Language becomes a way to map and make sense of our reality.
So it's not just about memorizing patterns and regurgitating information.
Right.
It's about building like a mental model of how the world works.
Exactly.
And then using language to navigate and interact with that model.
Exactly.
Like we learned that hot means something that can burn us.
Right.
Not just a word that frequently appears alongside fire.
Exactly.
We develop a conceptual understanding of temperature, danger, physical properties.
Yeah.
And then language becomes a tool to express and manipulate those concepts.
Exactly. We learn language through embodied experience.
Yeah.
Through trial and error, through this messy process of making sense of the world around us. And it's that grounding in experience that seems to be lacking in current LLMs.
Okay.
They might be able to manipulate symbols and mimic human language with remarkable accuracy, but they might lack that deeper connection to a lived reality, to the messy richness of human experience that gives language its true meaning.
It's like they're learning to speak without ever having lived in the world.
Yeah.
Without having felt the warmth of the sun or the sting of a bee.
That's a powerful way to put it.
Yeah.
And it highlights a significant challenge for AI researchers.
Okay.
How do you build a system that can learn not just from text, but from the world itself? How do you imbue an AI with the kind of embodied intelligence that we humans possess?
It almost sounds like we need to give these AI systems a childhood.
Yeah.
A chance to explore and interact with the world.
Right.
To learn through play and experimentation.
Exactly.
To build a foundation of understanding.
Yeah.
Upon which language can then blossom.
That's a beautiful analogy, and it's not as far-fetched as it might sound. There are researchers exploring these very ideas.
Okay.
Developing AI systems that learn to navigate virtual environments, interact with objects, and develop a rudimentary understanding of physics and causality.
So it's like training an AI to be a baby first,
Yeah.
and then gradually introducing it to the complexities of language,
Right.
allowing it to learn and grow in a way that mirrors our own development.
Exactly.
It's a long-term vision, but an incredibly fascinating one.
It is.
As we progress down this path, who knows what we might discover?
Yeah.
We might gain a deeper understanding, not just of AI,
Right.
but of our own minds.
Yeah.
The intricate dance between language, experience, and intelligence.
Exactly.
This research paper, it's not just about the limitations of LLMs, is it?
That's right.
It's a mirror reflecting back on us,
Yeah.
challenging us to examine our own cognitive abilities,
Exactly.
to appreciate the incredible feat of human language acquisition.
It is.
It's a humbling reminder that even in this age of rapidly advancing technology, some of the most fundamental questions about intelligence remain open.
Right.
We've come a long way in developing AI systems that can mimic human abilities.
Yeah.
But we're still grappling with the deeper mysteries of what it means to truly understand and learn.
And that, I think, is the beauty of this journey. We're not just building machines.
Right.
We're exploring the very nature of intelligence, pushing the boundaries of what we thought was possible.
So we end this deep dive not with definitive answers,
Yeah.
but with more questions,
Right.
more mysteries to unravel.
Yeah.
And that, my friends, is the beauty of knowledge.
That's right.
It's an endless exploration of the unknown.
Thank you for joining us on this intellectual adventure.
Yeah.
Keep questioning, keep exploring.
Yeah.
And who knows what we might discover together.
Until next time, stay curious.